welcome back to you. And the last previous class, I just stop up to here, is it right? We stop up to the value of d square v by d square, we got the value, and d square by d square, we got the value, is it right? So we just thought about the general equation of these two, is it right? Now what we do, we gotta go for making the solution in a huge dramatic way. I'm gonna continue from this, okay? So better for this, I'm just gonna delete something we don't want right now, guys. And please just delete it down, no problem over this one, no problem. And I hope that the equation is 5. So make a marker, this is 5 and this is 6. It's right very clearly here. I into e power psi x plus b into e power minus psi x, and I is equal to c into e power psi x plus d into e power minus psi x, make it as number 5, and this was number 6. And what I do is just going to delete all these things from the board. And right now what I do, I'm going to make a separation of this one. So first what I do, I'm going to differentiate this 5 with respect to x. So that means what? dv by dx, which is equal to, what I do, as the constants go outside, when I differentiate e power gamma c power psi x, the argument will come to the before of this multiplication, because if we go by differentiation, big power argument get multiplied. So whatever in front of x will be getting multiplied in front of this e. So we have the psi, only psi is available in front of x, and e power psi x. And then afterwards, this minus psi will be coming, so it only will be minus psi. Before that, I'm just going to write b into minus I have written over here, and e power minus psi x. That's kind of about the dv by dx, is it right? And now what we just have, so we know that what's dv by dx? dv by dx we know, which is equal to, what's that one? dv by dx equal to I into z, is it right? So it's got I z. So very simple. So what I do, making a comparison of these two equations, I'm eliminating the differentiation. That means what, we don't want the difference. We want only the perfect current. Is it right? So I got this I z equal to I into e power. So here I got by the psi is right, a psi into e power psi x, and a minus b into psi into e power minus psi x. That's all. So what we do afterwards, now I'm going to have the small just substitution right here. What psi? It's a propagation constant, right? You know the propagation constant, which is having the root of z into y. You know, go back to the previous video and you can find about this psi value just equal to what? A into root of zy into e power root of zy into x, and minus b into root of zy into e power minus root of zy into x. Is it right? And that's all about this parameter. And right now what I do, I'm going to have the z to be taken to the denominator. So I will be getting one in the I. Z. That means what? So we should know about the current value of our house, because each and every house will have the separate power supply and separate current values, right? So for this, because the current is coming from the transformer through some resistors and capacitor storage, and it is somewhat storage and somewhat leaving. So likewise, it's coming through more and more objectives and more obstacles. Is it right? That means it may be a checkpost. So we should know the perfect current means. This is the formula, because protruding through, this current is coming protruding through resistor, capacitor, the inductor, capacitor, each and everything, it is going to get protrude. So after finally it is coming to be here. So I is equal to what? A into, so look at, okay, root of zy divided by z means what? Root of y by z, because root z by z means 1 by root z. You all know, is it right? So here also e power is a root of zy into x, and minus b into root of y divided by z into e power minus root of zy x. This is the value of this current, and this is going to be right now. And the next step, what we're going to do means we are going to make dv by dx to be replaced by di by dx, the same step. So what these things we did, and now we are going to do with the form of a di by dx. Okay, and very simple. So don't worry, it's going to wrap up this one. Please listen over here. I'm rubbing over here. I'm rubbing over here. I'm rubbing on this one. Just go with the rub on. Yeah, now I come back to the point. Here what I just had, I had with the di divided by dx. So I'm going to differentiate this equation number 6, and I got over here. Is it right? So previously what you have, you got the I value is right. So last equation you make the mark as equation number 7 because the 6 is right. Now what I do, I have d by dx. So here c into, you take this one, psi into e power psi x, and afterwards plus d into, so here the minus will come, is it right? So minus I write over here, and psi into e power minus psi x. You got it, is it right? And automatically you know about this one, what's di by dx. Everyone knows that di by dx is equal to v into y. You check about the previous videos, you know about the previous videos, okay? And that's very more important out here. And now what I just should have, I gotta have EC, and then afterwards psi into e power psi x and minus d into psi into e power minus psi x. It's equal to c into root of zy into e power root of zy x minus d into root zy into e power minus root zy into x. And now we got a vy, is it right? You make the y to be done because we know the word, we should know the word, is it right? Previously we got the value of the current, is it right? And now we should know about the value of this voltage. So I got the voltage equal to c into, what's this? Root of zy. So root by y. That means what? 1 by root by. So already root is right. So I got a root of z by y e power root zy into x, and minus d into root of z by y, and I got for e power minus root zy into x. I got the point, is it right? And now you make this equation in the form of an equation number 8. I'm sorry, 5, 6, 7, 8. Yeah, that's right. So this is up to a particular level. And now what's the next step? What I just going the next step means now we just assume that distance is to be 0. And that's going to be the next step, okay? So please wait for the next step. The next step we just going for the next video. We got about this point, is it right? And now what I just had, we got the value of voltage and we got the value of current, because this current is not be dominant because it's passing through more and more hurdles. And when it comes to the home, that home should get necessary perfect current as well as a perfect voltage. Then only your EB persons, they are coming and getting reading from your main meter box, is it right? So they should know about this value of I, and we then only they can able to just come to know about the power consumption in a particular home during the period they allotted. Okay, thank you. We'll see you in the next video.